Hello developers, let's start developing. My name is Veko and today we're gonna be taking on the 20th task of the Advent of Code for 2021. And I've taken a look at the task, I've read through it, and I didn't notice but I've been told the trick. That this is the first time this year that we have actual tricky input. Because I will explain it later, but you see, the example has a dot here and a hash here, and the real input has a hash here and a dot here, and those things will get important. So, basically our input consists of two things. The first one, the first line, is the so-called image enhancement algorithm, and the next part is the actual input, which is an image, two-dimensional grid of light pixels and dark pixels. Doesn't matter what is light, what is dark, but it's this and this, white and black or whatever we do. So, we have some kind of an alternative on the game of life or something like that. Which means that for each dot, in each step, we need to get it and its 8 immediate neighbors. So for that point, we are getting those three and those three and those three. And then we use that number that we get as a binary number or a decimal number. So we use that number as a lookup into the algorithm line, and that is the next value of that pixel. And so far so good, it would have been okay. But the question arises, so what do we do with the ones that are on the borders because they don't have 9 items? Well, here is the thing. The starting input image therefore looks like this. The images operated on here are infinite in size. Every pixel of the infinite output image needs to be calculated exactly based on the relevant pixel of the input image. The small input image, small region of the actual infinite input image, and the rest of the input image consists of dark pixels. Okay, so this is a problem. Which means, why is this a problem? Well, this means that if we have this top left corner, which can be it can be any coordinate. So imagine a coordinate that's out there in infinity and it has all zeros, all dark pixels. So what do we do in the next step? Well, if it's all dark pixels, which means if it's 0, then turn it into a 1. And if it's all light pixels, turn it into a dot, into a dark one. Which means that basically our image will somehow be oscillating. So on each step we will need to basically, this whole infinite thing, we will need to flip it. I have no idea how we will accomplish that. I think that we will constrain ourselves to some realistic sounding subset of that. And these are the first two steps for the input, for the original input. And you can see that we are getting a nice image or whatever. So this is the original, we are enhancing it once, we are enhancing it once more, and we get something. And we get that 35 pixels are lit. So as always, let's start on the example. Let's try to make it work for the example, and then we will think how to do or make it work for the actual input. And this is the first case when solving it for the example won't solve it for the actual input. We won't have a case when I just do a paste and everything works and I say we're done. So that won't be the case this time because of that initial thingy. So we need to read the lines. We need to read all the lines. Const map. I will call this. I won't call it the image enhancement algorithm. I will call it simply a map. So the map is lines of 0. Split it on a dash, and then we have basically a list of, we have exactly 512 of those, since it's 2 to the 9th. And we just need to make this into an array, I would say. Array of, yeah, let's use dots and dashes. So we have an input interface, and that input will have a map, which is not a number, but yeah, let's use dots and dashes. Dots and hashes, and hash array. So it is an array of items, and those items can be dots or dashes, or hashes. And then we have the image, which is a matrix of these. Okay, so then we get the map, and then we can just do lines dot slice off the first two, because the second one is an empty line, and then we have all the lines, and we can just map every line to be split, and that's the image. We can just return the map and the image. That's all there is. Only we will need to convince our solution that we are indeed using that. Now this complaint, because we just have no guarantee that this will produce only dots or hashes, but let's see if that is the case. Yeah, we have this as the map, and we didn't need this as the map, but for the image it looks like we have what we needed. No, also no. We are splitting on a comma, and we need to split on an empty string, because we need each character separately. Yep, so this has, by default, the console log shows 100 items, so this is 512, correct? And we have our image here. Yeah, we can change this so that it displays. Okay, it works. Now, let's think what we need to do. For each of the items, we will need to have to run the algorithm. So I will, as usual in these cases, use Excel, and let's have it as square as possible. Come on. Actually, no problem. Text to columns. This is a fixed width and split it on each and every character. I think it did what I wanted, but not in the way I wanted it. Yeah, this looks better. Let's add a bit of conditional formatting. Format style. Yeah, cell value equal to dot. If it's a dot, then that's dark, and that's, yeah, black. Okay. That's equal to dash, and that should be bright green. Let's do a bit. So the font color should also be bright green. Yep. So this is the image we were starting with. Something like that. And now we need to determine the next step. And this is the situation that we need to assume. That this is the data we actually have. So we need to calculate the next step for each of these. So what cells will not have a 0 by definition, or a 511? So which cells could be different? So this cell is only using one of those, so I will mark with an X the cells whose value can change. Yep. This is the set, so nothing outside of the X's will be able to change its value, because they already have a predefined, which looks very much like the trick that we did with the expanding, if you remember. But now that trick with the expanding won't really work, because we actually need to expand it. And we kind of know, even for our real case, what these values are, because these are the values that we haven't used so far. So let's copy this over. So we have this situation, and when I needed to copy, and I cut, copy, paste. So this is the situation that we have, and I will remove all of this. So for this we will need to calculate for this as well. So we need to expand it, and that's our new value, and then we need to expand it once more. so that we can calculate this thing easily. So on this grid I can calculate anything that is green on black or X quite easily. So yeah, that makes sense. And this axis in our case will be dots. Actually, we have two cases here. If and only if, so if the first element is a dot in the map, that means that these elements are always dots. But if the first element is a hash, that means that on the zeroth step they will be dots, because that's how we started. On the first step they will be hashes. On the second step they will be dots again, because all of the hashes go to dots. So we have actually these four scenarios, and we will only need to take care of two. So if we have a dot and a dot, the result will be dot 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 dot. If we have a hash and a hash, for example, the result will be, we're going to start with dot, and that dot will move to hash, and then that hash will move to hash, and we're going to have hashes all the way. If we have a dot and a hash, we're going dot 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 dot, because we never managed to get a hash, because we started with dot and we're continuing with dot. But this is the actual situation that we have. And so we're going to start with dot, and the dot will become a hash, and then on the next step the hash will become a dot, and on the next step the dot will become a hash, and we're going to go back and forth like that ad infinity. So yeah, this will be okay. And I will actually create a function for this. That will be, what color will be the infinity stones be, and we're gonna need not an input, we're gonna, you know what, I'm gonna do this. Yeah. No. Technically it's correct, semantically it's completely different. So this is a matrix of those, so it's not an array of maps. And the map is a map, and the image is an image. So we're gonna need to get a map as an input, and a step, which is a number. Start is map of 0, and is map of, I'm gonna hard code this, since this is 2 to the 9th minus 1, and it can only be one value, and it can only be 9. And I will be eating these words if something else comes up in part 2, but for now it's gonna be pretty stable that 2 to the 9th minus 1 is 511. So if start equals dot, return dot. And since we're using types a lot, we're gonna use this as well. This is pixel. So a map is an array of pixels, and an image is a matrix of pixels. So get infinity stones returns a pixel. Yeah, we can see that if we are starting with a dot, we never get to a hash. So if the start is not a, because right now start, and this is the good thing about TypeScript, because we already start can only have two values, and we check that it's one of those values. So if we here, it has to be the other value. Start actually has the type hash. That's the only legal value that the start variable can have. So we don't have to worry about it. And now we can say if end is equal to hash, let's start with that scenario, then we need to, if the step is the zeroth step, it's a dot, otherwise it's a hash. So step equals 0, it's a dot, otherwise it's a hash, and we need to return that. And now in this case we can have that start and start is definitely a dash and end is definitely a dot, a hash and a dot, so we need to return. Now if the step modulo 2 is equal to 0, then we have a dot, otherwise we have a dash. Let's test it out. How do I generate a map? Let's remove this 511 because I don't want to do that. I want to just get the last one. And I can say for something like this, only use 20. If we have dot dot and index, don't do this at home. Never use plus equals with strings in a loop, but this is a trained professional. I know what I'm doing. I have no idea, but let's see. We're getting the result, but we didn't log it. So we got nothing. So we got all the dots for this case. For the case with dot and hash, we should get all the dots again. For the case of hash hash, we should get first a dot, then a series of hashes. And for the interesting case, when we are inverting the world on each step, let's see what we have. Yep, that's what we need. Speaking of this on a slightly more serious or unserious note, there will be a lot of visualizations online for this task. So, Epilepsy Alert. Basically, if somebody tries to visualize 20 steps of this, it's gonna be a lot of blinking going to darken light. So we have the getInfinityStone method, which will give us the color, the stone type of the infinity around us. So we will know what the x's and what the y's are. the x's and the y's have the exact same value. Only the x's are the interesting ones and the y's are just here to help us, so that we don't have to write boring code. Actually, why? Why? Let's try that. So we have our original image and we need to expand it. Will it guess what I want to do? Map the image and then to a binary? No, I don't want to do that. Well, this is an array, so I want to map those as well. We don't need this. Line.slice will be enough because we are using character strings. So right now image is a pixel matrix, which is a copy of the original image. We don't want to break our original image, we'll need it for part 2 at last. So array of, yep, and fill it with dots. Map each line to a dot line dot, and one more when we have that. Let's print the expanded one. And of course I have a print matrix method that actually does this nicely. It will print it as I want it to print, and I have it in a nice way. Okay, so now our expanded matrix looks quite nice, and we need to calculate its next step. So this is not the expanded, I'm gonna call it this step matrix, step image, because this is the final image for this step, and based on this image we can move to the next step. So this is actually the image that we will need to produce the new one. Am I making any sense? Not really. So let's get back to this. So we have a 5 by 5 matrix. In order to produce our next image, which will be a 7 by 7 matrix, 2, 4, 7, we need to create a 9 by 9 matrix in order to generate the 7 times 7. So yeah, let's do this. So this is the expanded. Yeah, let's do that. And the expanded will be, let's have some other number. So if this was 10 by 10, the next one will be 12 by 12. And we will need a 14 by 14 matrix in order to generate it, because it will be to this way, to this way, to that way, to that way. Yep. So we're gonna have to do this plus 4, and we're gonna add a dot, and we're gonna add another dot, and we're gonna add, and actually we're not gonna be adding a dot, we're gonna be adding infinity. get infinity stone for this, using this map for this step, and this is the step that we're on, it's step 0. So we're gonna add infinity, and this is a pixel. Yeah, we're gonna add 2 infinities, and then the line, and then again 2 infinities, plus 4, and fill it with infinities. And this is our expanded, not expanded, expanded array. Let's see our expanded array, and it should be as for the 5 9x9 matrix. Okay, we expanded it in one direction but not in the other direction. We got a 7x9 matrix and we needed to get a 9x9. Yep, 2 lines above, 2 lines below, 2 lines to the left, 2 columns to the left, 2 columns to the right. Yeah, that is our properly expanded matrix. And now what we need to do is, why are we expanding the image? Basically we need an empty line Oh, we need 2 of these. First of all, we need the original expanded image, and we needed to expand it using the infinite. That one expanded using the infinite. But then we need to actually calculate everything. Oh, in order to calculate everything, we need to calculate it for this as well. So we might have better luck if we expand it. No, this is okay. The expanded one is okay, because now we can say no idea what this does. No, shut up. We need to loop through each row, starting from row 1, going up to -1, and for each column this is not row, this is an index, so this will be its index. And we have no guarantee that this will actually be quadratic, so row dot length -1. So for each item of our expanded matrix, because we have one expansion, that is one that we need and that we're gonna color, and that is this one, the axis, and then we need one more expand for the y's, and the y's we are not painting, we just need them for calculation, because for this x we will need to take care of these 5 y's. So now we can say that is the lookup that will be this array, so to say, expanded of row index -1, its index -1, and Yeah, it's guessing them correctly. We're taking 9 items from the row up, 3 from the row above, 3 from this row, 3 from the row below, and then we can just join them together using an empty string. Let's see what we get. If I'm correct, we should get a lot of outputs of random dot dash strings. Yeah, we're getting something. Dot dash, dot dash, dot dash. Yeah, you can see that it's kind of moving, but who cares? That one is all dots. Do we have such a point? I don't see it. Let's look at it here. Do we have a black point where all the other points are black as well? Yeah, this one. And this one. Anyway, so let's just, at the first we should get a few zeros, I think. How is the first one? Yeah, the first one only has a hash at the last position. The second one only has the hash at the next to last position, third position, last position again. Looks kinda correct. And now we need to actually, what we need to do is transform each of these into a binary. So if we will need to do the replacement, and replacement is I guess the light ones are ones. Yeah, the dots are zeros, those are ones. Well, we can do it after the fact. And we're gonna do a very simple version of replace. We're just saying replace dot with 1 and replace dot with 0 and hash with 1. There should be a method called replace all. There is, I think, but I don't know, depending on the version of Node I have, it might not work. Yep, that is relatively recent, but I think that I can have it if I use a regular expression. I almost hope that we will get by without using regular expressions. No, still works just for the one. Yeah, we either need to loop and replace things, or we can say if this is equal to that, then it's 1, otherwise it's a 0. And actually it's even better to use the string 1 and 0, because as we're doing join, they're gonna get transferred into a string anyway, so why not use them as a constant? Why did I copy a pipe? Yeah. Let's see it now. Yep, looks like binary numbers, and then we can do, this is the lookup string, and we can parse it. and display the actual lookup. This should be some random number between 0 and 511, and it kinda is. Okay, seems that we have the lookup. And so once we have the lookup, we just need to say, well, input dot map of lookup oh I guess we need the lookup input dot map of lookup, that's the value of our new array for this step, and we need to define that new array. The result is actually we can get the expanded. No, let's take the image and this is gonna be bigger this is gonna be bigger than the image by 2 lines, one left, one right. So we're gonna need this and we're gonna need this, and in the middle, not expanded but image, and we don't want to do this, but each line we can just map each line to this. Or let's just use the line since we already have the line. Yeah. So if we have a 5 by 5 array, using result we are making a 7 by 7 array that is all filled with dots. And now we are running from this to this, which is actually a 7 by 7 loop, because for a 0 to 8 we are running from 1 to 7 to 8 actually. Yeah, from 1 to 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that's 7. And then we are getting that lookup, and now we can just say result of, and we need to be off by 1 because this starts from 1, of index minus 1, index minus 1 is equal to this. And print the result. Let's see what we get. We got something alright. So we got this, and we were supposed to get this. So now we get to do the fun part and compare this with this. Well, at the start we have 4 more lines of dots, and then we have something like that many dots on the side. And then we have that many dots on the other side. It looks similar, but why I did this was so I was able to do this. Yep, we matched it. So what I will do now is extract all of this to a method. We need to step the image using the input, and I will add another parameter which is called step, which needs a number. and this will be the step. So we're copying the image, we are getting the infinity stone, we are getting the expanded that we need to work with, we are initializing the result, we're filling the result, and then we are returning the result. And this takes an input and a step and returns a image. I will put this high above. And I always say I prefer variables to functions, function variables to functions, because that way I know that they are defined, so I don't have to worry where they are and how they are implemented. So we have the step image function, and then we have actually let's change it a bit so the step image doesn't take an input but takes a map that is a map and an image that's an image. Are we destroying it? Not really. But we need that. So we're gonna need to do input.map and input.image, and then that's step 1, and print matrix of step 1. Looks kind of the same. Let's go through the motions again. 4 dots, I guess. Yeah, this is enough. Yep, found it. Okay, we are correct for step 1. So in order to get step 2 to run, it's that. Print step 2, and it should expand once more. And we got this, and it says that we need to get this. Where we have 3 lines on that, 3 dots on this side, and 3 dots on this side. Let's just check. Yep, got the correct one. And now, of course, counting the pixels would be trivial. Step 1, so we need to count the lit pixels. Step 2, reduce each line, and while we are reducing it, yeah, we're gonna reduce starting from 0 because that will be sum, and accumulator plus, yeah, exactly that. Filter only the lit pixels, take their length and add it to the accumulator, and we can do this. Return lit pixels. It says 35 lit pixels. So let's get to our input. It's a much bigger 100 times 100 array, and let's see how that thing goes. I'm just putting it without debugging, without anything, because I'm either a genius or a stupid, but it's much cheaper to try if you maybe are a genius. And of course, I am. Yeah, humble to the core. Uh, so that's the right answer, and we're one go start closer to finding the sled keys, and let's see. Maybe we didn't enhance it enough. We still can't quite make out the details in the image. Maybe you just didn't enhance it enough. Yeah, and I think we need to do some CSI things on this so that we can see all of it. A total of 50 times. Oh! So this will get to be quite a huge image. Let's try brute force. So of course we're not gonna write a lot of step 1, step 50, but let's just move to the small one and try if this works. So limit equals 2, and then let image equals input.image. The input map is always the input map. For, and it's not index, this is step. Step equals to that, step less than limit, step plus equals, image equals step image input map of image, and this is the step. Let's and let's see if this thing provides an identical result to the first part, because our limit is 2. 35, 35. So what happens if the limit is a bit bigger? And let's just finish step. That ran fast. 3351. 3351. So it wasn't slow even for the last thingies, and when the image length was getting to be significant, because it rises by 2 on each step. Yeah, it's 105 at the end. So let's keep that console, because we are starting from 100, and let's see how this thing goes. It went whoosh. Let's see, maybe this is the correct one. Yep, that's the right one answer. And so thanks to the nice and thought out algorithm that we did for the first part, basically the second part was trivial. And fortunately I was able to do this analysis on the dots and the hashes. Otherwise, we would have a lot of problems if we just assumed that the infinity is just dark all the time. No, it goes dark, dark, light, dark, light, dark, light. But it turns out it's not that important. It's only important when we're calculating it. And so now we can fully remove this and just run it in the nice scenario. No debugging, no printing anything. And the first part is 45 milliseconds, the second part is 865. I don't think that we can optimize it a lot. Maybe because it's relatively straightforward. Maybe we can, yeah, this is not the problem. This nested for loop is the problem when we're generating one from the other. Maybe there's some way to do this faster, for example, but yeah, because this is essentially the slowest way to get a binary value out of those dots and hashes, but it's operational. Yeah, is there an easy way to actually well, yeah, let's try that. Since these are actually bits, we can say let lookup. Since we have a working solution, this is kind of getting to optimize it, so I will just comment this part out for the moment. And yeah, I will just take what I need. So since these are bits, I can say lookup is 0. And then we can have this, as this will be kind of maybe longer but a bit more efficient. If that thing is 1, actually we're not adding 1, we're adding 256 because that's our most significant bit. And then we have this and we're adding 128, and then we have this and we're adding 64. That's the first line, and now we just need to do it for the second line and for the third line, and I'm gonna make a mistake somewhere. For the second row we're just removing -1, for the third row we're just adding +1. So if each of them is a hash, we're adding 32, 16, 8, 4, 2, and 1. So after this we have all our bits inside lookup, and let's take a stab. Maybe this is faster. It should be. Ooh, it's about 3 times faster, 2 times faster, let's say. So we halved our processing time just by doing a proper binary calculation instead of doing string to binary manipulation. And to be honest, I don't think that this is much uglier than this one, because this one is plenty ugly on its own. Yeah, so we kind of unroll the loop and try to do it this way. Do we need this assignment? We kind of don't. This won't speed up anything, but it will make for some nicer looking code. Yeah. So because we are running in the millisecond range, we won't always get the same time, but just something like that. So we have Yeah, this is relevant. This is, I would guess that this is slow as well, because we're doing a huge map and everything. We could avoid the expansion and then just have a lot of ugly code here that says, but wait, if r index minus 1 it does not exist, or if c index plus 1 is bigger than the length. And to be honest, this time I'm exchanging memory and speed of execution for cleaner code, because this is uniform on the x or on the y-axis, and this I can understand what it's doing. And once I know the expansion trick, actually this is the expansion trick, this is some variation on that theme. So if we know the expansion trick, we can use it, and basically we're training some memory and some processing time for easier understanding of the code. And to be honest, 296 milliseconds is fine by me, even if I run all my programs, and I'm not running task 19 at this time, because task 19 is something like 10 minutes. I run all my tasks using task 19 yesterday evening, and it turns out that by itself it basically floods out everything else, because it's 99.3% of the execution time. So right now this task is just 7%, and we still have task 18, task 14, task 11 to optimize, and of course we have task 19 to optimize. So you should add about 10 minutes to these 3 seconds that we are running. As I said, my goal is to have everything run in under a minute. Once, if I get task 19 to behave properly, and I think I have an idea how to do that, I think I'm gonna call it a day. So we got our 2 stars, that's great, and talk to you tomorrow when we're gonna be solving the task for day 21. Bye for now.